record it. Let's see if I can. Okay. So we're working with quadratics, and in particular, in the first part, we're working with quadratic equations. In the second half, we look at quadratic functions, which are very much related, but they have, kind of two variables, an x and a y variable. But in the beginning, we're just looking at equations, and a quadratic equation is one that can be written like that. Okay, so and we've seen quadratics before, but we only had kind of a little narrow slice of how to solve them. So for example, we've seen ones that look like x squared minus 2x minus 24 equals 0. So that's a quadratic equation, and it's important that we would remember that we solve this by factoring, right? So when we have quadratics, we want to look at that and try and factor it. And maybe it takes us a couple tries or a little bit longer, right, to come up with that factoring. But eventually we factor it and we break it down, and each of these factors generates a solution for us. And it's not surprising, we expect two solutions, right? When we work with quadratic equations, we're always on the lookout for two solutions. So what our goal is in this section is to really figure out what other kinds of quadratics we can solve and what other techniques we need in order to solve those other kinds of quadratics. So this works great for certain kinds of quadratics, but unfortunately, factoring doesn't solve all the quadratics that we're interested in. So, for example, x squared minus 5 equals 0. It's a quadratic too because it has an x squared, but it doesn't factor using our kind of normal factoring tools. It's two terms. This is not a perfect square, this 5. So it doesn't factor for us. But it does still have two solutions. And in fact, every quadratic that we see has two solutions. They might be the same solution, so it might be like 3 and 3 here. But as long as you say that's okay, then we have two solutions to every quadratic. And so that's really our goal in the first half of chapter 7, is to be able to solve all the kinds of quadratics, even the ones that don't factor. And the first kind of tool that we need is called the square root property. And it's actually not super complicated. It says if x squared equals a number, then x equals a, or, sorry, the square root of a, or x equals minus the square root of a. So what this is it's telling us the solutions to a quadratic of a particular form, x squared equals a number. Then you can do this. And we often are kind of lazy, including myself. So we will write plus minus a. But when you put the answers into My Math Lab, you're going to have to write them out separately. There's no plus minus there. So you have to write the positive and the negative. So this one here is perfect for this square root property. Not surprisingly, right? I wrote it out expecting. I moved the 5 over, and the square root property says my solutions are plus or minus the square root of 5. two solutions because it's a quadratic. A lot of students think that you are sort of taking the square root of both sides. That's not exactly right, because if you just took the square root of both sides, you would sort of get x equals the square root of 5, which is a solution, but you'd miss the negative one. So you just got to remember that you get two of them when you do this, and one's positive and one's negative. And this also works for other types of things, like x squared plus 9 equals 0. That also can be turned into one that fits the square root property. It's a -9, but after our work in the last section, we know that that value is an imaginary number, but those are still two numbers. So imaginary numbers are fine here. A lot of our solutions are going to be imaginary, and I still get two solutions. This property even applies to things that are a little bit different looking. Here we have not just x squared equals 7, but 2x minus 3 equals 7. Well, it turns out that's not that different. This part inside has to equal plus or minus the square root of 7. If I square it, then I would get 7, right? Either one of these values. Now I just have to do a little bit of extra work here to figure out what x is. And it is easiest to just work with the plus minus and keep it here. You could do these separately, like plus the square root of 7 and then minus the square root of 7, but you're going to end up with the same answers either way. So if you add a 3 to both sides, you can just do 3 plus the square root of 7 and 3 minus the square root of 7. And if we divide by 2, sorry, we get an answer that looks like that. So the square root property is actually pretty nice. In some ways, it's even easier than factoring, but it only applies to certain problems. When we have things that are squared equal to a number, right? So x squared equals 5, or 2x minus 3 squared equals 7, or x squared equals minus 9. We couldn't do the square root property with this problem because it doesn't have that form. So this one we would still have to do by factoring. But we can see the square root property does allow us to solve equations that are certainly more complicated, or we wouldn't be able to solve this by factoring, right? Factoring would never give us these two answers. And that's somehow something different. Questions so far? Okay. Okay, so here's a quadratic. If we had seen this one before, we would have subtracted the 7 from both sides to get 0 over here. That would have given us x squared plus 10x plus 18 equals 0. And you try to factor this, but it turns out it doesn't factor. You're stuck. You know there's two answers to this one, but we don't know how to find it from this form. If you look carefully at this part over here, you'll notice that it factors. Now, normally, it's not helpful to factor something if it's not equal to 0. Like that first problem we saw, if I factored this, but it wasn't equal to 0, it turns out that wouldn't be helpful. It wouldn't tell me what the answers were. If this was 8 here, I wouldn't know anything about the solutions. But in this case, the factoring is going to be kind of special, because it's x plus 5 and x plus 5. And that gives me x plus 5 squared. And this, you should notice, looks just like the last problem we did, right? Something squared equals a number. That's a square root property. I can subtract the 5, and there are my two solutions. So you may be saying to yourself, that was pretty lucky. What are the chances that it factored and it was exactly the same factor? That's the only way that problem worked, right? And clearly I set that up to do that. But what if instead I had given you this version of the problem? So you didn't start with this very convenient x squared plus 10x plus 25. Well, if we were feeling very clever here, I could move this 18 over to the other side. And then I could just add something here. As long as I do it to both sides, that's not going to change the equation. And what should I add? We already know because we already solved it over here, right? It's 25. But if I hadn't done this one, it turns out that the number I want to add to both sides is half of this number squared. That pattern is going to create a perfect square trinomial, one that factors perfectly as this x plus 5 squared. So 10 over 2 is 5, 5 squared is 25. I would add 25 to both sides. And that is going to put me right back into this problem. This process here is called completing the square. It's completing the sort of missing part that makes this a perfect square. So here's a trinomial, a quadratic. We're trying to solve it. If it's me, the first thing I'm looking for is that square root property. Like those are the kind of quickest and easiest. If I have that, I'm going to just solve that using the square root property and not think about anything else. This one, unfortunately, does not fit that square root property as it's written. Okay, so I got to move on to something else. I might take a look and see if this one factors, right? Because factoring, if you get it factored, then the answers come really quickly. The problem is sometimes it's hard to factor, right? And a lot of times what you get doesn't factor. So I don't want to spend too much time trying to factor this one if it might not even factor, right? But sometimes you are going to get lucky and you've saved yourself some work there too, right? So I'm looking for the square root property and I'm looking for factoring. It turns out this one isn't going to factor. No matter how small I make the factors here, they're always going to add up to more than 6 for this middle term. So it doesn't factor. So time to try out our shiny new toy here, right, of completing the square. So the process that we're going to do is we're going to move that 15 over to the other side. I don't want that constant in there kind of mucking things up. I want it out. So I can focus on what I'm adding to both sides. And just like before, I'm going to take half of the middle coefficient. So 6 divided by 2 is 3, and I'm going to square it. So I'm going to add 9 to both sides. You got to do it to both sides, right? Otherwise, you change the equation. That gives me x plus 3 squared. So when you factor this, you're going to get x plus 3 and x plus 3. You're always going to get half of this middle coefficient, right? Half of 6 is 3, x plus 3. Half of 10 is 5, x plus 5. Minus 15 plus 9 is minus 6. It's okay, negative numbers are fine. I know I'm going to get an imaginary solution here, but that's okay. X plus 3 is plus or minus the square root of minus 6, right? That's the square root property. X equals minus 3 plus or minus I square roots of 6. Questions about this process? There's 2 things that actually we got kind of lucky with. Not lucky, I wrote the problem, but 2 things that I chose to make the problem easier for us. The good thing is that the problems you see in your homework are also going to be of this easy form, but I just want you to be aware of the fact of what makes this process work. This value here has to be a 1. Like just x squared. If it's 3x squared, it's not so easy. I have to do some different things to make it work. We can still make it work. You can still do it, but it's not as simple. And the other thing, of course, that made this kind of easy is that when I divided 6 by 2, I just got 3. If this were 5x, then when I divide by 2, I get 5 halves, which gives me a fraction. It still works, but then I have to do a lot more operations with fractions. I'm not going to give you ones like that. Okay, I'm going to give you these kind of straightforward versions. And the reason for that is because we move on past completing the square. So completing the square is a really good method, but it's really a hassle if you have a number here or you have a messy fraction when you divide it by 2. So you can do it, but it's a lot of extra work. And so what we want is a little shortcut to completing the square. Right? So we're going to use that shortcut whenever we can. And that shortcut is called the quadratic formula. So what happens is if you have a quadratic equation like this, and you do the completing the square process, keeping track of what happens to A, B, and C. And it turns out you have to divide everything by A, and then you gotta multiply or divide this term by 2 and do that factoring and do the square root process and move things around just like we did there. We could totally do it. It would take us about 5-10 minutes. What we would get in the end is we would get x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And this is the quadratic formula. This would be an excellent thing to write down in your notes if you don't already know it or are worried about forgetting it, because you will use it on the final exam. The beautiful thing about the quadratic formula is that it solves any quadratic. That's worth 2 exclamation points. All of our previous methods were good, but they only worked in certain situations. We really like things that work all the time, and that's what the quadratic formula does. The bad thing is that it is and can be hard to simplify. So the work in it is in the simplification, and that can be a little messy. So let's just see how it works. Let's do it with this problem here that I had. X squared plus 6x plus 15 equals 0. I know what the solutions are already, so hopefully this will confirm it, and we'll see how it operates. So we have to figure out the a value, the b value, and the c. In this case, a is 1, and b is 6, and c is 15. Those are only numbers. We're never going to include the x's with them. So the quadratic formula says I take negative b, so the opposite of whatever b was. If this was minus 6, it'd be plus 6. This is plus 6, so it's minus 6 plus or minus the square root of b squared, which is 36, minus 4 times a times c. And that whole thing is divided by 2 times a. I don't actually need the ones in there because they're multiplied, so they're going to drop out, or they won't impact the problem at all. I get minus 6 plus or minus the square root. This is 36 minus 60. 4 times 15 is 60. So 36 minus 60 is minus 24. And you might be saying, well, wait a second, these are the answers. This isn't quite like that. Well, we're getting there. We're still on this simplification stage. So 24 minus 24 is going to give me an I. And the 24, remember, is 4 times 6. This is why we need to do that radical section before we could do the quadratics. So square root of 4 is 2. And the square root of 6 just stays in as the square root of 6. And so the last step here is to divide the 2 into both of these terms above. You have to distribute that division. So the 2 goes into the minus 6, which gives me minus 3. And the 2 divides the 2i square roots of 6, which gives me I square roots of 6. And we see that's the same solution that we had before. Now, I think in this case, you could make a reasonable argument that this completing the square was actually a little bit easier than this quadratic formula. They're pretty close to each other, but you know, do we really need the quadratic formula? Well, it turns out we do, because this completing the square one was one of our very simple forms of a quadratic for completing the square. It had a nice even number here, and it had no coefficient on the x squared. So if you have that kind of problem, you're welcome to complete the square and get your answer. That's fine. But if you have a 3 in front, or a 2, or anything in front, or this is an odd number, I would really stay away from trying to complete the square. We haven't done any. You have to divide by this. It gets very complicated. Right? So we want to use the quadratic formula in most cases. So the hierarchy here is still, number one, look for the square root property. Number two, factor if possible. We don't want to spend a ton of energy factoring, because a lot of these won't factor, in which case it's kind of wasted effort. And even if they do factor, if there's really hard factoring, it may be more challenging than our other methods. And so after that, we really want to follow the quadratic formula. So this is to solve, sorry, bad handwriting, the quadratic. And I'll put a little asterisk here, a little star. Complete the square only if asked. So I do want you to know how to complete the square, because that's where the quadratic formula comes from. So if you don't know how you complete the square, then the quadratic formula is sort of like magical, right? And we don't like that. We like to know where things come from. And so completing the square is the process. So I will ask you on the final exam to do a problem. It will be similar to this kind of problem, an easy type, by completing the square. All of the other quadratics that you see on the final exam, you'll be welcome to solve whichever method you prefer. You'll save yourself some time and energy if you do look for the square root and factoring first, but if you solve them all with the quadratic formula, that's fine too. Okay? So I'm not going to, except for that completing the square process, I'm not going to be picky about which style you use to solve these problems. Questions about that at all?
Can you do problem number 2 and 3 from Take Homework, similar question to that?
Let's take a look. Yeah, so 2 is yeah, just one that it's a quadratic. 5x squared minus 4 equals 3x. So when you see one like this is a quadratic. So we want to think through that hierarchy. Can I use the square root property? No, because I don't have an x squared equal a number. Can I factor it? Well, maybe. I'm going to move this 3x over. Oh no, I mean, maybe this is kind of a harder type of factoring with the 5 in front. Just glancing at it, I don't see immediately how it might factor. So for me, I'm going to say, I don't know. It may or may not factor, but I'm not going to spend any time factoring it because I don't see it immediately. So I'm going to fall right to the quadratic formula at that point. So negative b, which is plus 3, plus or minus the square root of b squared, which is 9. That's always positive, right? Because you're squaring a real number. So I get 9 minus 4 times a times c. The whole thing is divided by 2a. Be very careful about the sign here. A lot of the errors I see from quadratic formula problems, people mess the sign up. They end up with a positive when it should be a negative, or a negative when it should be a positive. So when I do this one, I think right away, okay, minus and minus, that's going to be a positive. So I know this is going to be 9 plus, this is 20 times 4, which is 80. So that's going to be 89. Now, I have to look and see if I can simplify 89 at all. 4 doesn't go into it. 9 doesn't go into it. 16 doesn't go into it. 25 doesn't go into it. It's not, doesn't have any perfect square factors. So this is actually kind of our best case scenario. There's no simplification of the radical, and I can't then cancel anything. So these are my two answers. Okay. Questions at all about that problem or using that process?
Yes, so if 89 was to be factored down, for example, do we divide after that by 10?
So yeah, what you have to do, so this 10 needs to divide into both of these pieces. So
Okay.
that's the other spot where people make some mistakes with simplifying. So for example, if I did end up with 5 plus or minus 3 square roots of 7 over 10, let's just say that that's what I ended up with.
Mm-hmm.
This would be a fine spot to stop. I cannot just cancel the 5 here with the 5 and the 10. So a number of students will end up with something like 1 plus or minus 3 square roots of 7 over 2. They'll kind of cancel these 5s. But that doesn't work because the 10 has to be divided into both of these terms. So the only way you're going to cancel or reduce something is if you get a common factor in both of these places. So for example, if you ended up with 4 plus or minus 2 square roots of 7 over 10. Here I have a factor of 2 in both of these terms. So I can cancel that 2 with the 2 in the denominator. You don't always have to actually factor it out like that, but that's what happens. So I'm going to kind of see the difference in those two types of problems. Okay. The second type of problem you asked about was kind of a different type. Those are called quadratic in form. So the idea of this section, and this would be your third section in the homework. So if you're working on the take home, you'll want to make sure you've completed that, through at least this before trying that that homework problem. Quadratic in form means even though it may not technically be a quadratic, x squared plus x plus c, we can still solve it using those same methods. So one example is x to the 2/3 plus, say, 5x to the 1/3 plus 6. Let me make that minus. Sorry, messy. So this one very clearly is not a quadratic because these exponents are quite different. But it turns out that that first term can be rewritten as x to the 1/3 squared, and then I have 5x to the 1/3 minus 14. So this is actually very similar to this quadratic. One thing you can do is actually make the substitution and replace the x to the 1/3 with a y, and then solve it in terms of y. And that's, I think, often the way the book does these problems. But you can also just do it by keeping track of the x to the 1/3. And it turns out when you do these quadratic in form problems, they are going to factor for you. You could use the quadratic formula and get those values too, but it becomes complicated because then we have to do some more with those solutions. So it turns out that these are always going to be set up so that you can factor them. So you can kind of work a little harder to factor these because you know that's going to work. So the pattern is the same as a quadratic. X to the 1/3 times x to the 1/3 is going to give me this squared term. And then the middle terms are both going to be some kind of x to the 1/3, and those are going to add up to 5. And the constant term has to multiply to give me minus 14. So it turns out you have to have that, plus 7 and minus 2. And if you're thinking about it as making a substitution, you would get the same, sorry, minus 2. That's how you factor it if you were looking at it as a y squared. So here you would get y equals minus 7 and y equals 2. But you'd have to remember that it's not y you started with, it's actually x to the 1/3. And notice we're getting the same result here from this factored form. This product is 0. So x to the 1/3 has to equal minus 7, or x to the 1/3 has to equal 2. Right? Same result, whether we do this kind of replace it with y and then go back to x's, or whether we keep track of it with x's all the way through. It's really your choice, what you feel comfortable with. We do have to do a little solving here. This is really a cube root of x. So to get rid of that cube root, I would cube both sides. So x equals -7 cubed, or x equals 2 cubed. That's 8, of course. Remember what 7 cubed is. 49 times 7. 343, I think. Minus 343. Okay. So the homework problem is sort of a different style of these, but it's all of these in this section work the same way. They are actually quadratics in disguise, right? Or quadratics in form. So we want to try and break them apart in order to solve them, right? And we can do that using a sort of substitution style or just a regular factoring style. For example, we could also have x to the 4th plus 5x squared minus 14 equals 0. Or x plus 5 square roots of x minus 14 equals 0. Or 2x plus 3 squared plus 5, 2x plus 3 minus 14 equals 0. These are all different problems, but they're the same structure underneath, where this piece here is squared for that leading term. Square root of x squared is x. 2x plus 3 squared is 2x plus 3 squared. In the same way, this squared was that. So all of these versions, I would really do it in the same way. I would factor them out. This one, it would be x squared plus 7 minus 2. This one would be the square root of x. And this one would be 2x plus 3. So there's some differences, but once you see them, they really are kind of the same problem underneath. Okay. Hopefully that's helpful. Any other questions? Okay. This kind of material we talked about covers through the first 3 sections of the homework.